You're listening to DTFHN for August 13th, 2026. I'm your source available and vaguely haunted host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where every download link gets a threat model before it gets a thank you. Today is about who holds the keys, who welded the door shut, and what people build anyway. Crack the case open. The commenters didn't debate whether it was good. They debated whether to let it near their file system. Top of the thread, someone writes, treat these as Trojans. Run them isolated. Give it a full desktop and a VM if you want to. Just not direct access to your system. That's not a hater. That's a person describing standard hygiene for a tool they probably use every day. And underneath, the observation that does the real work. Unlike the Codex CLI, Codex Desktop is proprietary, and thus can't be audited. Think about how a restaurant kitchen handles trust. You don't taste every dish to know it's safe. You have an open kitchen, health inspections, a supplier chain someone can walk. The trust is structural. Now imagine a place that says the food is excellent, the chefs are frontier grade, and the kitchen door is welded shut. The food might genuinely be excellent. That's not the point. The point is, you've been asked to swap verification for reputation, and reputation is a thing that can be spent. The desktop app is Electron, which drew its own round of commentary. A framework whose entire pitch is shipping fast across platforms at the cost of performance. Somebody asked plainly, what's the benefit of this thing, which eats insane amounts of memory, over the CLI? Nobody in the thread had a great answer. The CLI is open. The CLI is auditable. The CLI doesn't want a persistent process sitting in your session tray. Here's the part worth sitting with. A GUI installer is a permissions laundering machine. The CLI makes you type the sandbox flags. You see the boundary because you drew it. A double-click installer defaults to your primary user account, and one commenter went further. It makes it much easier to trap people into running this with admin privileges without a second thought. Same capabilities, different friction, wildly different blast radius. But the encouraging thing is where the standard landed. The community's baseline expectation is now. Show me the source or give me the VM. That's a real shift. 5 years ago, the response to a shiny new dev tool was a download link in a screenshot. Now it's a threat model in the first 3 comments. The engineers who built this are almost certainly good at their jobs. The Codex PR reviews catching bugs. That's real. People are shipping with it. The decision to close the desktop client while leaving the CLI open wasn't made by them, and it tells you exactly which surface the company considers the product and which one it considers the demo. Run the CLI, read the source. That option still exists, and it exists because someone chose to leave the door open. That door open thing is a nice segue, because here's something nobody can close. Mathematics. Story 2. The lattice of sets of natural numbers is rich. I built a scheduler once that ran on a priority queue of integers. Every task had a slot. Nothing could ever sit between slot 4 and slot 5. The structure forbade it. When a customer asked for just slightly higher priority than this one, I had to rebuild the whole thing on rationals. Discreteness is a property of how you count, not of what you're counting. Joel David Hampkins wrote a piece about the lattice of all sets of natural numbers, and it's about exactly that mistake. The setup is simple. Take every possible set of natural numbers. Order them by containment. A sits below B if A is inside B. Empty set at the bottom. All of the naturals at the top. Singletons 1 rung up. Their complements 1 rung down. Finite sets clustered near the floor. Cofinite sets pressed against the ceiling and in the vast middle. The primes, the squares, the square-free numbers, and uncountably many others. Now, the first principles question. What orders live inside this thing? The counting numbers, obviously. Empty set, then 0 and 1. Climbing forever. Hampkins notes something precise about that ladder. Every rung is finite. Every rung is right next to the floor. And yet the ladder has no upper bound except the top of the entire lattice. You climb to the heavens without ever leaving the ground. Flip it, and you get a rope of cofinite sets dangling down from the ceiling, every knot near the top. No lower bound, but the empty set. Then the integers start at the set of odd numbers. Add even numbers one at a time going up. Remove odd numbers one at a time going down. Discrete steps in both directions, unbounded at both ends, and then the rationals. A dense order. Where between any two things, there's always a third. In a structure where the nearest neighbor of any set is one element away. It's there. Hampkins finds it. The apparent discreteness was an artifact of only looking at the sets that differ by one element. The article is on his personal site. Math typeset in the open. No paywall between you and the diagrams. This is the oldest form of the thing we keep rediscovering. A person works something out and puts it where anyone can read it. The lattice was always rich. Someone just had to write down the map. So a mathematician maps a lattice by hand and gives it away. What happens when an entire frontier lab does the same thing with weights? Story 3, DeepSeek V4 Pro 0813. What is a model actually worth? Not what it cost. What it's worth, because those numbers have been drifting apart for 2 years now, and DeepSeek V4 Pro just yanked them into different zip codes. The listing is almost aggressively boring. One provider, throughput, latency, time to first token. Uptime over 30 days. A benchmark table with a rank percentile. It reads like a spec sheet for industrial bearings. And then you get to the comments and someone mentions they burned $12.50 running 2 billion tokens through it, with 50% cache hits on a distributed physics engine, and has found significant performance gains without breaking anything. $12.50 for work that would have been a contractor invoice. Let me argue the other side because someone should. The pessimist case says this is bad. Commoditization eats the research budget. If inference costs collapse to nothing, nobody funds the next architecture. And we all coast on cheap copies of a frontier that stops moving. Race to the bottom, everybody drowns. It's a coherent argument. I've heard smart people make it. It's also just empirically not what happened. The cheap open-weight models didn't stall the frontier. They set the floor that the frontier now has to justify itself against. One commenter puts it flatly. What I care about is whether the model can do the task at the lowest cost. Right now, they're running Kimi GLM Minimax. Sonnet is great, they say, but I burn through tokens too fast. That's not disloyalty. That's a market functioning for the first time. And here's the unintended consequence nobody planned. The thing that made these models cheap was open weights. Publish the weights, and every inference provider on Earth competes to serve them at margin. You cannot rent-seek on a file that anyone can download. The price floor isn't a strategy. It's a structural property of having given the thing away. Another commenter tested it on a real task. Scan a repo. Generate a single Docker Compose file. Deploy behind Caddy specific port ranges. Not a benchmark. It Tuesday. Somebody else complained the bicycle chain rendered fine, but the little basket with the fish landed in the wrong place. That's where we are. The model does distributed physics optimization for the price of lunch. And we're filing bug reports about basket placement. The tools exist. The weights are on disk. Go build something. So, the Frontier model builds you a deploy pipeline over lunch. But what happens when a bug hides in plain sight for 16 years? 19. That's the number in the Tailscale post that stops you. 19 separate database corruptions over 6 months, not one freak event. 19, each one meaning an engineer got paged, a shard went dark, and somebody's whole control plane vanished for an hour while they rebuilt a file from a snapshot. And the bug was 16 years old, sitting in SQLite, the most tested piece of software on the planet. 92 million lines of test code against roughly 150,000 lines of actual database, running on billions of devices. Nobody hit it, because you only hit it when a WAL-reset races a reader at exactly the wrong instant, under exactly the load Tailscale was putting on it. Here's the detail worth sitting with. When Tailscale finally cornered it, they didn't just file a report and wait. They funded an open-source VFS shim. A shim layer that sits under SQLite and intercepts every file operation, so you can replay the race deterministically instead of praying it happens again in production. They paid for it, and then they gave it away. Run that forward. That shim now exists for everyone. The next company that hits an impossible SQLite corruption doesn't spend 6 months in forensic. They pull the tool off the shelf. Tailscale's pain got converted into permanent public infrastructure. That's what the bootstrap actually looks like in practice. Not a manifesto. A debugging tool released, because releasing it costs nothing and helps everyone. There's a second thread here about testing. One commenter pointed at deterministic concurrency testing. The technique where you take a system, control its scheduler, and systematically explore the orderings that reality only produces by accident. SQLite's test suite is legendary, and it still couldn't find this, because you cannot brute force your way through concurrent interleavings by writing more test cases. You need a different method. Dijkstra said it in 1970. Tests prove the presence of bugs, never their absence. So the answer isn't less software. It's better tools for finding what's already broken. 16 years of a bug hiding in the most scrutinized code base we have. And the fix came from a company that hid it, paid to build the instrument that could see it, and then handed the instrument to the rest of us. The tools exist now. That's the point. 2 stories in, and we've got a bug hunt from 1970 meeting, a model that didn't exist last quarter. Story 5. 95 billion parameters activated, out of 2.4 trillion. That ratio is the whole story. A model that holds the knowledge of something enormous, but only wakes up 4% of itself to answer you. The architecture deserves a close look, because it's genuinely clever. 92 layers, but they're not uniform. The pattern repeats 23 times. 3 blocks of gated DeltaNet feeding a mixture of experts. Then 1 block of gated attention feeding another mixture of experts. 3-to-1. Linear attention doing the bulk of the work. Full quadratic attention showing up every 4th block to do the expensive thing that only it can do. 512 experts in the pool. 10 routed plus 1 shared expert active at any moment. 262,000 tokens of context natively, stretchable past 1 million. That's not a scaled-up transformer. That's someone who looked at where the compute actually goes and redesigned the traffic pattern around it. Now, the part that matters. This is on Hugging Face. Weights. Config. The whole thing. Compatible with VLLM, with Sklang, with the inference stacks people already run. Qwen shipped their max class model to open release for the first time. The Fraktur model and the downloadable model are the same model. Apply the test. Who holds the off switch on a set of weights sitting on your own disk? Nobody. There's no objective function anyone can change out from under you. No deprecation notice. No pricing page that moves next quarter. The API version has extra features. Vision. Built-in tool. And that's a fine business, but the capability floor is now public and permanent. The commonist went straight to the practical problem, which is the correct instinct. BFO16 and FP8 only at launch. No quantization-aware training at 4 bits. So it's hard to serve today. Then someone posted the unsloth 1-bit quant. 397 gigabytes. One person did the math out loud and bet that the hardware to run this properly, unquantized, at speed, drops under $10,000 by 2040. Another said the thing I keep coming back to. I can download it now and get the hardware later. That's the asymmetry. Weights don't expire. Hardware gets cheaper on a curve we can actually predict. Every open release is a bet placed on a future that keeps arriving. Now, a complete change of scale. That was a 400 gigabyte bet on the future. This next one is about what happens in the delta. Git has a resolution problem. Its atomic unit is the commit. A snapshot, frozen, addressable. That's why it works. But it means everything between commits is invisible. The false start, the reasoning. The moment you told the agent no, do it the other way. Git never saw any of that because Git only records the destination. That's the constraint Zed is engineering against. Their answer is DeltaDB. And the architecture is worth admiring. It replicates the work tree itself, not commits, the live uncommitted working directory, in real time across every participant, each with a full local copy on their own machine. Conversation and code replicated in the same structure, so comments anchor to lines that keep moving underneath them. On a commit-based platform, a review comment points at a snapshot and rots the instant someone rebases. Anchor it to a replicated work tree instead, and it tracks the code as the code changes. That's a genuinely hard distributed systems problem, and they solved it while keeping the underlying Git repo completely normal. Your teammate who never installs Delta clones it and sees nothing unusual. The browser client deserves its own moment of appreciation. They didn't rebuild it in JavaScript. Same Rust application, compiled to WebAssembly, rendered through WebGL. Open a link and you get the actual editor, not a degraded imitation of it. Now, the question nobody in that thread asked. Git is open. Anyone can implement it, host it, fork it, walk away with everything. DeltaDB is the layer holding the part that Git was never able to hold. The reasoning, the intent, the why. And that layer is not open. So, the most valuable artifact of how software gets made in an agent-driven world would live somewhere you cannot self-host and cannot export. The commenters circled it without landing on it. One compared it to Slack. Fine for hashing things out. Terrible as a decision record. That instinct is correct and the reason is architectural. Slack owns your decisions. Git owns your code. The gap between them is exactly where Delta is building. Zed shipped their editor open source. They have earned real credibility here, which is why the interesting thing to watch isn't whether Delta works. The engineering suggests it will. It's whether DeltaDB follows Zed out into the open or becomes the piece that stays behind. Zed earned that credibility by shipping. Now, a 100-year-old logic textbook that turns out to be doing something we're only just catching up to. DeepSeek Alan Newell and Herbert Simon fed a program called Logic Theorist the propositions from Chapter 2 of Principia Mathematica. It proved 38 of the first 52 theorems. For one of them, it found a proof shorter and more elegant than Whitehead and Russell's own. Russell, by then in his 80s, was reportedly delighted. The journal that Newell and Simon submitted to rejected the paper because a co-author was a machine. That's where the first AI program came from, not a vision document, a textbook from 1910 that someone had actually read. Oleg Kizelyov has been reading Chapter 1, and the notes he published are startling. Page 8 of Principia contains what looks like the first statement of referential transparency in the mathematical literature. If P is equivalent to Q, then F of P is equivalent to F of Q. Substitute equals 4 equals. Then, immediately, the counterexample. A believes P. A context where substitution breaks because belief is about the shape of the thought and not just its truth. Whitehead and Russell had the monad problem in 1910 and knew exactly why it was a problem. There's more. Alpha renaming, domain, type. In the sense your compiler means it, free and bound variables, with the observation that all of this comes from linguistics, not mathematics. They're incomplete symbols. The ones that only mean anything in context are recognizably ancestors of continuations. Kizelyov's read is that lambda calculus is already sitting in there 20-odd years before Church wrote it down. And the reason nobody knows this is the 1,000 pages. The proofs, deliberately excruciating, written that way so no unstated premise could sneak through. That's a proof assistant implemented in ink and human patience. Because in 1910, that was the only substrate available. The ideas are in the preface in Chapter 1. The rest is the machine check, which is the part worth sitting with. The book everyone jokes about. 1,000 pages to get to 1 + 1 = 2, has been scanned by the University of Michigan and is sitting on the open web right now. Free. The barrier was never access. It was that the format punishes readers, and we built better formats and then stopped going back. Kizelyov went back, found a programming language's text with a 116-year head start. Kizelyov dug up a 1990 textbook. Now let's talk about the fight over how German letters should look. Paz story, the Antiqua Fraktur dispute. The strongest argument for Fraktur is the one nobody bothers to make anymore, so let me make it properly. Adolf Reinecke, 1910, laid out the case. German script is more compact. More words per page, faster word image recognition. It's better adapted to German orthography, to the umlauts, to the long compounds. It's still developing where Latin script is set in stone. And it doesn't cause nearsightedness. That last one is nonsense, but discard it, and the rest is a genuine argument about legibility and cultural fit. Bismarck refused gifts of German books printed in Antiqua. Returned them. Goethe's mother told her son to avoid the un-German letters. For God's sake. Take the principle to its end, though. If a typeface can be German, then reading becomes a loyalty test. And that logic has a destination. 1941, the normal Schrifter loss. The Nazi Party abolishes Fraktur. The script it had spent years wrapping in blood and soil rhetoric, and mandates Antiqua. The stated reason was that Fraktur was actually Schwabacher Jewish letters. This was fabricated. The real reason was administrative. They were occupying Europe, and nobody in Paris or Warsaw could read the paperwork. The nationalist typeface lost to the logistics of empire. Follow the thread all the way and the whole premise inverts. The people who insisted a script carried the German soul, killed it the moment it became inconvenient. Which tells you the ideology was never in the letter forms. It was projected onto them. And projection washes off. There's a detail in the comments worth holding. Far-right groups in Germany today print Fraktur on shirts and car decals. They are using as a symbol of their politics, the exact typeface their political ancestors banned. Nobody checked. The symbol got detached from its history and floated free. And the people flying it are the ones who least understand what they're flying. Oliver Heaviside campaigned against Fraktur in mathematics. German letters must go, on the grounds that they read poorly in equations. That's the honest version of the argument. A script is a tool for moving information into a head. It succeeds or fails on that, and only that. The most durable fact here. Antiqua won because it was interoperable. Not because it was right. Not because anyone convinced anyone. It won on interchange, the way formats always do. The widest reach, the fewest translators required. 2 segments in, and we're already deep in typography wars. Story 9 goes further back, to the machine that taught information to hold still. The comment that lands hardest under this piece is the one nobody enjoys writing. Go out to the world and look at what the tabulator was used for, because the IBM history page says, itemize, categorize, and compile data on all kinds of products and people. And that sentence is doing an extraordinary amount of quiet work. Hollerith was a 20-year-old clerk in 8/8 handling manufacturing statistics. And he did what every good engineer does when confronted with tedium. Q refused to accept it. The 8/8 census took 8 years to process. 8. The country was growing faster than the counting. By the time you had your answer, the answer was wrong. His machine cut the 8 times 90 count to about 1 year. That is a genuine, enormous win. And I want to give it the full weight it deserves before anything else. A guy got annoyed at a manual process and built the foundation of mechanized data processing. Punch a hole, close a circuit, advance a counter. 1s and 0s, before anyone called them that. Then it got license. Railroads, department stores, utilities, Austria, Canada, Cuba, France, Norway, the Philippines, Russia. 60+ years of variations, generating what IBM's own page calls exorbitant profits. Here's the deadpan part. A tabulator does not know what a column means. The card has fields. The fields hold whatever the operator decides they hold. Hollerith built a general-purpose instrument for counting people by category, sold it as a service, kept the machines, leased them, and controlled the cards. And every national government that bought one got a very fast, very accurate answer to whatever question it chose to ask about its own population. The Third Reich, the Holmag subsidiary. The 1939 German census. That is not a malfunction. The machine performed exactly as designed. The lesson isn't that Hollerith was a villain. He wasn't. He was a clerk with a good idea about circuits. The lesson is architectural. He built a capability, kept it closed, and rented it to anyone with a checkbook and a census. Nobody outside the company could see what the fields were for. The off switch was in Endicott, New York, and it was never pressed. We are building general-purpose category machines again, at enormous speed. Build them faster, but build them where people can see the column. Moving on. I built a thing once that watched for a specific string in a data stream and acted on it. Simple. Then, the upstream started padding the string with junk, and my matcher broke. I patched it. They padded differently. That loop has a name in biology. coevolution, predator and prey. Each generation slightly faster than the last, neither ever winning. Just running to stay in place. That's the war uBlock Origin has been fighting with Facebook, and this week the maintainers stepped out of it. No more Facebook ad filtering. The stated reason is exactly what you'd expect from people who have been doing this for a decade. The platform is a full-time adversary with a full-time budget, and the filter list is volunteer work. The technical detail deserves a straight look. A user tried to block the word sponsored using the element picker and discovered Facebook splits that word into individual letters, each wrapped in its own tag with randomized class names. Sometimes the letters are out of order with fake characters inserted, reassembled visually by styling. That technique has been running for roughly 5 years. Engineers are paid very well to build markup whose only purpose is to be unreadable by the people looking at it. Consider what that means as architecture, rather than as grievance. Facebook's advantage here is not that it's smarter, it's that its code is closed and the filter lists are open. Every filter uBlock ships is public the moment it ships, and Facebook can test against it before anyone notices. The defender publishes, the attacker observes. That asymmetry is structural, and no amount of volunteer effort corrects for it. The way out is the one commenter named. Stop parsing the adversary's markup and classify the rendered pixels instead. A model that looks at the screen and identifies an ad by what it looks like to a human is immune to obfuscated spans. Because Facebook cannot obfuscate the thing the user has to be able to read. The attack surface collapses to something they can't move without breaking their own product. That is a solvable engineering problem, and it's getting cheaper every month. uBlock's maintainers earned the right to put this one down. Somebody should pick up the harder version in the open, where the rest of us can build on it. This has been your daily tech feed for Hacker News for August 13th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now, go leave a door open behind you. We'll see you back here tomorrow.